I'm going to do two examples from section 8.5, solving rational equations, and Jones and I decided we're going to wait on the inequalities if we do those. So for today, the first one, solving rational equations when there is more than one term on one side. So this one has three terms equation because it has the equal sign. So you're not just simplifying like we were earlier in the week. We actually have to solve, which means that we come up with a solution for x. So we're going to end up with an answer x equals something. And the way that we are doing these in class is to find the least common multiple of the denominators, and then we're going to multiply each term by that least common denominator. So for ours, for this first problem, least common multiple for the denominators, we have an x, a 4, and another 4. So these two are already the same. Least common multiple needs to have that 4, and it also needs the x for the first one. So we are going to multiply all three of these terms by that least common multiple for x. And it's not like when we multiplied to get common denominators where we multiplied it on top and the bottom. We are just going to multiply the 4x. I kind of put mine out on the front. You can put it on the top. You could put it over here. 4x and 4x. And what this is going to do for us is it's going to clear out all the fractions so that we don't have any fractions to work with anymore. So you need to go through and simplify or cancel out from each one of those terms. Something should cancel every time, and you shouldn't have a denominator if you used the correct least common multiple. So for the first one, x's will cancel, and you're left with 4 times 1 is 4. On the second one, 4x over 4, the 4's cancel. So you have minus, there's an x there from the 4x that didn't cancel, times 3 is 3x equals, and on the last one, the 4's will cancel again. X times x is x squared. When we have an x squared, we have a quadratic. This one has three terms. It has an x to the second, an x to the first, and a constant. So to solve those, we need to have them set equal to 0. I'm going to move the 3x to the other side by adding it, and move the 4 by subtracting it. And I'm just going to move them over all in one step. 0 equals x squared. This will become positive when I move it to the other side, plus 3x, and the 4 becomes negative, so negative 4. And now I'm going to factor. Since a is 1, the leading coefficient is 1, I don't have to go through the grouping method. I just find two numbers that multiply to negative 4, so factors of negative 4 that will add to 3. So I get x plus 4 and x minus 1. Remember, we're solving. We're solving an equation, so I want to actually figure out what x equals. If this is equal to 0, then the solutions for x are negative 4 and positive 1. And don't forget to go and check for extraneous solutions. Plug negative 4 and 1 back up in there to see if they actually do both work. I'm going to let you do that. The second one I chose was number 20 because this one's a little bit different. This one only has one thing on each term, or on each side. So you could go through, I think the book actually has you multiply by the least common multiple again, but I cross multiply. So Trevor, don't do this fish. You're going to cross multiply 4 by n minus 3. And that's equal to the other diagonal, 5 times n minus 4. I write it this way to remind me that I have to distribute, so I remember not to just do 4n minus 3. I have to distribute the 4 through. So we get 4n minus 12 equals, distribute the 5 through, 5n minus 4, and then solve for n. And again, make sure that it's not an extraneous solution.